Polynomials. And it is pronounced polynomial. Polynomials. I think some of you are really going to enjoy this unit and these lessons right now. Just because it's kind of stuff that we've already been dealing with. We're just focusing more on it and how it's built. So this first part, these first 2 pages are kind of more definitions and characteristics, and then we'll start adding and subtracting here in a little bit. So the word polynomial is made up of poly, which means many. Do it in green. Poly, which means many, and nomial, which means term. So when you put that together, polynomial means many terms. Many terms. Polynomials just means many terms. So it says in the tables below, we're going to learn some more. A polynomial is an expression Polynomial is an expression with one or more algebraic terms. So what do you remember about terms? Like, what breaks up terms? How do we know what a term is? Anybody remember? They're separated by plus and minus. So it can be like 4x to the cubed is a term. At plus, if there's a plus sign, then the next term would be like 3x squared. Those are the different terms. A polynomial can include constants, variables, and whole number exponents. This is extremely important. Can include constants, variables, and whole number exponents. A polynomial cannot include division by a variable. So when we're looking here in a second, the next step that we're going to do is we're going to look at these 5 expressions to see if they're examples or non-examples of polynomials. And what we're going to look for is make sure that when it says a whole number exponent, that means it can't be negative, it can't be a fraction or decimal. Exponents have to be positive whole numbers. A polynomial cannot include division by a variable, but it can include divisions by constants. It just can't have the letters in the bottom. So those are the things that are going to make it not a polynomial. So looking at A, what do we see that's wrong? What makes this not a polynomial? The -3 right there. So A, the example A is a non-example, or expression A is a non-example. B, is B a polynomial? What do you think? Does it have a negative or fraction in the exponent? Is there a division by a variable? It includes constants, it includes variables, and it includes whole numbers exponents. So yes, B is a polynomial. I wish that table was just a little bit over, but. Okay, C, is it a polynomial?
No.
Why? I'm hearing no. Why do you think no?
Because there's a division by variable.
Division by a variable. Fractions are division problems, so yes. So yes, it is a fraction. So if the denominator of a fraction has a variable in it, then it is not a polynomial. So C would go in the X. Do we see anything wrong with D? Nope. D's good. D is a polynomial. What about E? Is it a polynomial? It is.
Oh yeah, D is a variable.
Like I said a little bit ago, it can be divided by a constant. It just can't have a variable in the bottom. So yes, D and E are both polynomials. D and E are both polynomials. Okay, so now that we know how to recognize a polynomial, we're going to start talking about the different characteristics of polynomials. The first one being the degree. The degree of a polynomial is the largest exponent of any term in the polynomial. So if you have x to the cube, x to the fourth, x to the fifth, what would be the largest exponent of those? 3, 4, and 5. What's the largest?
5.
5. So my degree would be 5. The standard form of writing a polynomial is to put the terms in descending order based on the degree of the term. In this form, the coefficient of the first term is called the leading coefficient. So what that means is you just put it in least to greatest as far as your powers. That's kind of the, when it says standard form, it's just good practice to always do things in order. So if there's different letters, you put it in alphabetical order. If it's a polynomial like this and we have lots of degrees, you put it in least to greatest. So descending, least to greatest. So looking at this would be our leading coefficient. The 2 would be our degree because it's our biggest power. And then each one of these, 3x squared, 4x, and negative 7 are our terms. And negative 7 is our constant. So that's kind of a visual representation with the definitions. So we have our powers from least to greatest. Also, constants go at the end because they're the power of that variable would be 0, which is equal to 1. So that's why it goes at the end. All right. I am going kind of fast, but we do have quite a few parts that we have to go through, and I want to give you plenty of time to practice and ask any questions if you need to. Also, if you're not done with the Renaissance, I'd like you to finish that as well. So, all we're going to do on this first problem, we're just going to rewrite the polynomial in standard form, meaning we're just organizing it. So, what is the highest power?
5.
5. So, I'm going to write 4x to the fifth. Then the next power would be 7x squared plus 15, right? So that's how to write it in standard form. It's literally just organizing it. What's our degree?
5.
Absolutely, our degree is 5. I mean, that's how we look for the degree. When we're looking at problems, the first thing we need to make sure is it written correctly, and then we can look at the degree. I'm not going to do the second one with y'all. I think you understand that part. It's literally what is the highest power and organizing it. I think today's lesson is not going to be as complicated as what the rest of what we're going to look at the next few days. But, okay, so now we can tell, we have the characteristic of the degree. We can determine if it's a polynomial or not. We can find what degree the polynomial is, and now we're going to classify it. Classifying it, a polynomial is classified by the number of terms it has in its most simplified form. So when it says most simplified form, that means all like terms have been combined. So if it's a polynomial that has one term, it's a monomial. Monomial. If it's 2, it's a binomial. Do you see the prefixes we're using here? Anybody want to guess what a 3 one is called?
Trinomial?
Absolutely.
Hey, got that.
Trinomial.
I said the capital.
So examples. I'm going to use the ones off the key. They give us 3x. That's it. That's one term. It's a monomial. If it's 2 terms, like negative 2x plus 3, that's 2 terms. So it's a binomial. If it's 3 terms, x squared minus 6x plus 10. 3 terms, trinomial. Past 3 terms, it's a polynomial. There is classifications for it, but I don't think y'all will ever need to worry about classifying. Okay, so let's look at the table. Looking at the first, we're going to determine if it's a polynomial or not. We're going to determine what the degree is, and we're going to classify it. So, looking at the first one, 5x squared minus 14x plus 15. Is that a polynomial?
Yes.
Yes. What is our degree?
2.
2. What's its classification?
Trinomial.
I'm just going to write try. But yes. Absolutely. Okay, x to the negative 5th plus 14. Polynomial. No, we have a negative exponent, so no. And I don't need to fill out the rest of it because it's not a polynomial. X minus 2.
Yes.
Yes. What's my degree?
0.
Not 0.
1.
1. Yes. If they're... Remember, anything to the 0 power is equal to 1. X to the 0 power is 1. 3 to the 0 power is 1. So if there is an x, then that means that the power is 1. Okay, classification.
Binomial.
Binomial. 18.
No. That doesn't matter. Question mark? Okay, it's a yes.
So, remember the two things that make it not a polynomial. Is it dividing by a variable? Does it have a negative or rational exponent, meaning decimal or fraction?
Oh, so it can have constants?
Yes, constants are a part of it.
Okay.
What would be my degree? What do you think my degree is here?
This one is 0.
This one is 0 because I don't have a variable. So that means it's really like 18x to the 0 power, which is equal to 1. So 18 times 1, yeah. So that's why you have, yes, that is a 0 power. What is my classification?
Monomial.
Monomial. Okay, last one, 7x to the x to the 7th power plus 5 divided by x.
No.
No, cannot have a variable dividing. Okay, so next we're going to start talking about algebra tiles a little bit, but I don't want to go through algebra tiles twice. So I'm going to go ahead and skip the rest of this part of the page. If you have any questions about it, of course, let me know. But now we're going to start talking about adding and subtracting. I'm telling you this right now. We've been adding and subtracting polynomials. Because all it's really doing is adding like terms. Just now we're going to be looking at more terms. So, polynomials expressions can be added and subtracted. In order to visualize what happens when two polynomials are combined, create a model of the addition problem below using the tiles. So, you can either sketch it, but this is when I would go to our lovely little... I'm going to see if I can copy and paste this. Oh, wrong thing. Red notes. Here we go. Copy. Paste. Boom. 2x squared. Well, it doesn't do the exponents, but we can figure that out. 2x squared plus 5x minus 3 plus x squared minus 2x plus 1. And on our notes page, it talks about doing, like, stacking them on top of each other. So we're going to do in algebra tiles, we're going to do the first equation, or first expression, 2x squared plus 5x minus 3 on top. And then we'll do the second one on bottom. And so we're adding it, so this kind of makes it a little easier. So we have 2x squared, oh, tidy. We have 2x squared. So there's 2 of the x squared tiles. Plus 5x, so 5 of the green ones that represent... Go up, thank you. Go over. 3, 4, 5. minus 3, so that's the red ones with the negative. Is anybody confused on how that represents 2x squared plus 5x minus 3? Any questions on that? Okay, now I'm going to represent this second equation. We have 1x squared minus 2x. Notice how I'm stacking, like I'm keeping the terms on top of each other, plus 1. Because I'll put it up there so it's easier to see. So we have 2x squared plus 5x minus 3 on top. And then we have 1x squared minus 2x plus 1. So in order to add them, we just combine. Combine like terms. So now we have 3x squared. That cancels out with that one. That cancels out with that one. The negative 1 cancels out there. So what is the answer? Somebody want to read that?
3x squared.
Mm-hmm.
3x
Mm-hmm.
minus 3x squared plus 3x minus 2.
Absolutely. So all we did was just combine like terms. So in our equation, back in our, record the sum of the polynomials. It was 3x squared plus 3x minus 2. So, if you're not understanding algebra tiles, do not worry. That is not the only way that we can use to add polynomials. Don't know what happened. So, that's kind of, you can, if you want to, you can screenshot in the visual representations or sketch it if you want to. I would go ahead and bookmark the algebra tile page because we will be using it in notes pretty much from now on, especially when we get to factoring. Okay, polynomials can be added by identifying like terms and adding the coefficients. So when we combine like terms, we just add the coefficients. How do we know if something is a like term? What makes it a like term? It has to have two things in common.
Have the same variable.
Same variable or same base, yes.
Same
Exponent, yes. Same base, same power, same variable, same power. However you want to remember that, that's fine. But the letter has to be the same and the powers have to be the same in order for them to be like terms. So, like I said earlier, we're going to be talking about different methods. Here's one step already. Or here's two different methods already. We have either the horizontal method or the vertical method. And we can use these using the commutative and associative properties. I pray that you kind of remember commutative and associative properties. So, what that means is I can go ahead and rearrange this because it's saying to add. So if I ignored the parentheses, I could rearrange this and have my like terms right next to each other. So 5x squared, what's the like term with 5x squared?
Negative 2x squared.
Negative 2x squared. So I'm going to write 5x squared minus 2x squared. Then the next one, 4x plus, what's my like term? And my second one?
Oh, 3x.
3x. All right, then I have negative 7. What's my like term?
11.
Negative 11. Make sure you keep... I know with a positive, or like if it's adding, we don't take the sign with it. But if it's negative, make sure you're keeping it as a negative. Or if it's subtracting, make sure you keep that negative sign. So, we've combined like terms. Now we just add the exponents. What's 5 minus 2?
3.
3x squared. 4x plus 3x. What's 4 plus 3?
7.
Negative 7 minus 11.
That's 18. Negative 18. Sorry.
Negative 18. So we have 3x squared plus 7x minus 18. Okay. Vertical method. The vertical method is a lot like what we just did with the algebra tiles. You just stack up the like terms. So 5x squared plus 4x minus 7, negative 2x squared plus 3x minus 11. So we look at the coefficients on top of each other. So 5 minus 2 is 3. X squared, 4 plus 3 is
7.
negative 7 minus 11.
Negative 18.
Thank you, Gabriel, since you're the only one that talks to me. Yes. It was the same problem, just showing you the two different methods. So you can either rearrange and have like terms right next to each other, or you can stack. Whatever helps you see it, whatever method you want, that is up to you. Okay, so that's adding. Adding is just combining like terms. We've done that a lot, haven't we? I think adding like terms should be a very easy thing for you to do, or adding polynomials. So let's make it a little more complicated and say subtracting polynomials. Subtracting polynomials is extremely similar to adding. Subtracting is the same as adding the inverse or the opposite number. For example, 5 minus 7 could be written as 15 plus negative 7, right? This one is saying when subtracting polynomials, rewrite the problem by as an addition problem by adding the opposite of each of the second polynomials. That's a really complicated way of saying distribute the negative sign. So we're going to take this negative and we're going to distribute it to each of the terms and rewrite it as an adding problem. So 8x plus 9 plus, parentheses, negative times 10x would be negative 10x. Negative times a negative 6.
6.
Plus 6, right? Yeah. So that's what it means. Just subtracting, just change the signs of the second polynomial and add them together. So we're still adding. We just have to do one extra step when we're subtracting. That's just change the signs of the second one. We're distributing that negative. So same thing here. We're going to take this and we're going to distribute the negative to each of the terms in the polynomial. Each of the terms. So rewriting that would be negative 4x squared plus x minus 3 plus 5x squared minus 9x plus 11. Is anybody lost on what I'm doing there? I'm taking that negative and I'm distributing it, meaning I'm changing the signs of each of the terms behind it. Yes, sir.
When you distribute the subtraction sign, like why does it flip to a plus?
Because it's like okay, so earlier, like up here, when we were talking about 15 minus 7 is really saying 15 plus a negative 7, yeah. Right? So it's kind of like we strip away that negative, we multiply it across to we distribute it to everything behind it, so that leaves me with a positive. Like I'm getting rid of the negative when I distribute it and change the signs. Oh. And so the reason why we're doing that is because we just learned how to add, right? The polynomials. So wouldn't we want to just do one little simple thing to make it to where we could go back to adding? Because adding is the easiest of our operations. So that's why. That was a good question. So looking at number 3 on our example, and then this is going to be the last, well, I'm going to talk about one more after this, so we're almost done. So 3x squared plus 9x minus 1 minus negative 4x squared plus 8x minus 6. I'm going to take that negative and I'm going to distribute it so I can make this an addition problem. And I'm also going to go ahead, I prefer the vertical method. That's just, I like it. I like things being lined up and in order. It makes my mind happy. If that's not the method you want, then rewrite it and then use the method you want. But I'm going to put 3x squared plus 9x minus 1. And then I'm going to rewrite that second polynomial after we've distributed. So negative 4x squared after distribution of the negative is a positive 4x squared minus 8x plus 6. I've just changed the signs. When I distribute that negative, I just change the signs. Add them all up. I've stacked the like terms. X squared and x squared. X, and then my constants. So that means I'm going to add the coefficients. 3 plus 4 is 7 squared. 9 minus 8 is 1. Just x. 6 minus 1 is 5. So we've just subtracted the two polynomials. How are we feeling about this?
Feeling good.
Feeling good? Okay. All right. The next one I'm going to look at is number 8. So over here, the very last problem. Matt's rectangular back patio has a total area of 12x squared minus 5x plus 1. So back patio, all of it. The outdoor rug, represented by the white rectangle, has an area of 8x squared plus 2x minus 4. Write an expression to represent the area of the gray region, the area not covered by the rug. So is that going to be adding or subtracting?
Subtracting.
Subtracting. 12x squared minus 5x plus 1. Subtracting, so that means I'm going to change all of my signs so I can keep it in addition. So minus 8x squared minus 2x plus 4. Combine like terms. 12 minus 8 is 4x squared. Minus 5 minus 2. What is that?
That's 7. Negative 7.
Negative 7x. 1 plus 4.
And 5.
That is adding and subtracting polynomials. That's all I have as far as my notes go. Let me make sure I stop recording this.